Hi everyone, welcome back. So in the last video we looked at the convolution equation. What we are going to do in this assignment is to see how we can use that convolution equation to both derive a unit hydrograph, and then we will also see how we can use that convolution equation to also apply the unit hydrograph to get direct runoff or stream flow hydrograph when we have excess rainfall information. So what I have given you here is excess rainfall and direct runoff. So in order to derive unit hydrograph, you need at least one historical event data. And in this case, I have already given you excess rainfall and direct runoff. If you were given total rainfall and total stream flow, you need to calculate losses from rainfall to get the excess rainfall, and then you have to also separate base flow from stream flow to get direct runoff. So that part is taken care of in this assignment, so we don't have to do anything. So we are going to use the convolution equation, so I will just rewrite that equation here. So Qn is equal to m equal to 1 and less than small m pm u n minus m plus 1. Okay, so in this case we have m, so m is the total number of excess rainfall pulses, so we have 1 2 3 4 here, and capital N is the total number of direct runoff ordinates, which is 9 in this case, and we have to determine the unit hydrograph. So the unit hydrograph will have n minus m plus 1 ordinates. So in this case n is 9 minus 4 plus 1 equal to 6. So we have 6 ordinates in our unit hydrograph, which means you need to find out u1, u2, u3 up to u6. Okay, so that will be our unit hydrograph once we have value for each u1, u2, u3, u4, u5 and u6. Now let's see how we can use this equation. So let's start with n is equal to 1. So if I do that, so q1 is equal to, so m is 1 and it goes up to small n, in this case which is 1, so we are going to have only one term, so m is equal to 1, so p1, and then this n is 1, m is 1, so 1 minus 1 is 0 and you are left with 1, so that gives you p1 u1. Now we know what q1 is, which is this, and we know what p1 is, which is this. So in that case u1 is equal to q1 divided by p1. So q1 is 10, p1 is 1, so you get 10 CFS per inch. Okay, now we can write the next expression for q2. So q2, so in this case small n is equal to 2, so m goes from 1 to 2 up to small n, so which means this will have two terms in this expression. So m is equal to 1, so p1, so n is equal to 2 here, so 2 minus 1 is 1, and then so this is p1 u2 plus, if you do that one more time, so in this case now m is equal to 2, so p2, so 2 minus 2 is 0, and then 1 u1. Okay, then now we know what u1 is, which is 10 CFS. So then you can solve for u2. So u2 now is u2 is equal to q2 minus p2 u1 divided by p1. So q2 is known, which is 120 CFS. p2 is known, which is 2 inch, and u1 is also known, which is 10 CFS per inch, and p1 is 1. So you can solve that and you can get you can get a value for u2, which is CFS per inch. And you will see that for all the U values that I'm getting, I'm writing CFS per inch, and that's how you will write ordinates for unit hydrograph, because the values that we have are per unit of excess rainfall. So in this case it's 1 inch. So that's why I'm writing CFS per inch for all my unit hydrograph. In this case we have done only 2. So I'm not going to write the value for this, or maybe we can do that. So Q2 is 120 minus P2 is 2, U1 is 10, and P1 is 1. So this will give you 100 CFS per inch. Now I'll write one more expression for Q3, and you will see that looking at this equation and writing each expression can be tedious, and if you make a mistake, then you can mess up the whole problem. So I will write this expression one more time, and then I will show you an easy way on how you can write this convolution expression for each Q. So let's write Q3. So in this case, this small n is equal to 3, and then what that means is m will go from 1 to 3. So this will have 3 terms in it. So P1, and then n is 3 minus, so U P1 U3 plus P2. I know how to do this, so I'm just going to write it. If you want, you can check it later. So P3 U1. Okay, so when you're writing this expression, you have to be very careful about looking at this convolution equation and make sure you don't make a mistake when you write these long expressions. So depending on how many excess rainfall and Q you have, this expression can become larger, which means it becomes little tedious. So this is one way to do that convolution equation. The other way, which I prefer, and this will also help you to do this in Excel, is to just create a matrix. So I'm going to create a matrix where the number of rows is equal to number of our n. So we have n is equal to 9, so I'll just create 9 rows. So number of rows is equal to n, and number of columns is equal to m, or capital M and capital N. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 rows. Okay. So this is just Q1, Q2, Q3, Q4, Q5, Q6, Q7, Q8, Q9. And then I'm going to create 4 columns. So we have 4 excess rainfall pulses. So this is our first column, this is our second column, this is our third column, this is our fourth column. And then in each column, so this is P1 U1. So we have 6 unit hydrograph ordinates from this expression here. Okay, so what I'm going to do this in the first column, I will just use P1 and then all the unit hydrograph ordinates. So P1 U1, P1 U2, P1 U3, P1 U4, P1 U5, P1 U6. Okay, so that's my first column. In the second column, I will not start on the first row, I will start on the second row, and I will do the same thing now. Instead of using P1, I'm going to use P2 because I'm in second column. So I'll just name this as 1, 2, 3, 4. So P2 U1, P2 U2, P2 U3, P2 U4, P2 U5, P2 U6. Again, same thing. Instead of starting in second column for the, or second row. For the third column, I will start in third row. So P3U1, P3U2, P3U3, P3U4, P3U5, P3U6, and one more time. So now we will start in the first row for the first column. So P4U1, P4U2, P4U3, P4U4, P4U5, P4U6. So now the way I'll read this is, now Q1 is equal to P1U1, Q2 is equal to P1U1 plus P2U1, Q3 is equal to P1U3 plus P2U2 plus P3U1. We don't need a plus sign here. Q4 is equal to P1U4 plus P2U3 plus P3U2 plus P4U1, and so on. So this is how I like to set this up, and if you set this up like this, you can also do this in Excel. So instead of trying to express this equation for each n value, you can just create a matrix like this and you have all the terms. Now, thinking back and looking at what we did in the previous video when we derived the convolution equation, let me see if I can sort of minimize this and put this side by side. So this is what we did last time. So here, if you look at the first column I have, let me just highlight this. So the first column I have here in the last video, this is what we did. Okay, so the first column is basically you multiplying the first pulse of excess rainfall with unit hydrograph. So the highlighted column that you see here is the first step that we did when we derived the unit hydrograph. So you can see this is all related, and now you can see how this column that I'm showing here in highlighted color translates to what we did in the previous video. Okay, so just to give you that connection or show you that connection. So once you do that, now you can write expression. So we already wrote expression for Q1, Q2, and Q3. Okay, so so we solved for U1, which was U1 is equal to Q1 divided by P1, and we got 10 CFS per inch. So U2 was Q2 minus P2U1 divided by P1, and then we got 100 CFS per inch. Yes. Oops. 100 CFS per inch. Then U3 will be Q3 minus P2U2 minus P3U1 divided by P1. So in this case, P1 is 1, so P1 is equal to 1 inch. So even if you don't write P1 here for denominator, it should not make any difference. But just to be consistent and correct, I'm writing P1 as denominator. So you solve that, so you have Q3, you know what P2 is, U2 is 100, U1 is 10, so you solve for U3 and you get a value. So similarly for U4, so U4 will be Q4 minus P2U3 minus P3U2 minus P4U1 divided by P1 again. Similarly, U5 will be Q5 minus P2U4 minus P3U3 minus P4U2 divided by P1. And then U6 will be Q6 minus P2U5 minus P3U4 plus P4 U3 divided by P1. So you have expressions for all U's and you have all the values for Q's, and you get the value for all the U's as you keep going down the row or down the column or for Q. So now you can see this is the expression that I have for U6. If I want, I can use this last row also to get value for U6. So in this case, U6 will be Q9 divided by P4. Then you may ask, will you get the same value for U6 if you use this expression versus this expression? And the answer is no. So you will get a different value for U6 depending on whether you start from the top row or whether you start from the bottom row. So that's a disadvantage of this method. So to be consistent in this class, or at least in this video, we will always go from top to bottom. Okay. If you want to go from bottom to up, it's up to you, but as long as we are consistent, it shouldn't matter. But in this class, for all your assignments and homework, I want you to go from top to bottom. Okay, so this is how you can use the convolution equation and use all the values for Q's and P's to get the unit hydrograph ordinates. Now I'm going to go ahead and give you all the values, so your job is to make sure that I did not make any mistake. So the values that I have, and the reason I'm giving you these values is also to show that there is another disadvantage with this method. So I will write the value for unit hydrograph here. So this is CFS per inch. So U1, U2, U3, U4, U5, U6. So for U1 I got 10. For U2 I got 100, which is we already did here. And for U3 I have 190. For U4 I have 75. For U5 I have 110, and for U6 I have 60. Okay, now if you plot this, I will again highlight. Oops, what did I do? If you plot this unit hydrograph, you will see that there is a sort of a dip when the hydrograph goes from 190 to 75, and then it jumps again to 110. So if I plot that, this is how it may look. So it goes from 0 to 10, 10 to 100, 100 to 190, and from 190 it goes to 75, then it goes to 110, then it goes to 60, and then it goes to 0. Okay, so this is how the unit hydrograph will look when you plot it. So this is a dip that we got, and this is another disadvantage of this method. So whenever you end up with something like this, you have to fix your unit hydrograph. So in this case, what we will do is we'll just take the average of this and make this something like this. So if you do that, instead of 75 here, you will take the average of 190 and 110. So 190 plus 110 is 300. So 300 divided by 2 is 150. So I will correct my value here. Instead of 75, I'm going to write 150. Okay, so this is our final unit hydrograph. I will again highlight this in yellow. So these are the numbers that we have for unit hydrograph after doing the first part of this assignment. In the second part, I am asking you to use the same unit hydrograph that we just derived to calculate a stream flow hydrograph for this rainfall event. Okay, So this I will I will do it in the next video, and for now I will stop here with part 1. I hope you were able to follow what I did. The assignment looks little messy, but if you follow the video you should be able to follow all the steps that I did in this. And with this I will stop here, and I will see you soon when we do part 2 of this assignment. As always, if you have any questions, feel free to email me, and I will see you soon. Thank you and bye.